Identity migration is more than moving accounts to the cloud. It changes architecture, security, devices, and day-to-day operations. In this course, we'll connect the why with the how, so you can design migrations with confidence. Here's the path we'll follow. We'll start with Active Directory foundations, then build modern Entra ID knowledge. From there, we'll design migration architecture, implement hybrid identity, move devices and applications, and finish with security, operations, and best practices. Expect about 20 to 30 hours depending on lab depth. Think of this course as a risk reduction path. Before you migrate, you need to understand the Active Directory environment you already have: domains, identities, groups, devices, and dependencies. Then you'll see how Entra ID changes the model, especially for cloud authentication, access control, and operations. With that foundation, migration design becomes a set of informed choices, not guesses. Implementation comes after design, with careful testing of sync, users, passwords, groups, and devices. Finally, modernization and security help make the new environment sustainable, monitored, hardened, and ready for everyday use. Use this course strategically based on your experience. If you're newer to Active Directory or Entra ID, start at Module 1 and move in order. Don't skip the foundations. If you're intermediate, work through the first 4 modules, then spend extra time where your migration responsibilities are deepest. If you're advanced, use the course as a reference, but still review assessment, architecture, rollback, and governance. Most importantly, study actively. Build diagrams, take notes, compare concepts to your environment, and ask questions that include both your current state and target state. Active Directory acts as the enterprise's central identity and access hub. Instead of every system keeping its own separate user list, AD stores trusted identities for people, computers, and servers. Applications and file shares can then ask AD, who is this user and what are they allowed to access? Group policy extends that control by enforcing settings like password rules, desktop restrictions, and security configurations across many machines. The key idea is centralization. Manage identity once, apply permissions consistently, and reduce the risk of scattered, unmanaged access. A domain is the basic logical container in Active Directory. It is a named security boundary tied to DNS, where identities, computers, groups, and policies are managed together. In this example, corp.contatoso.com is not just a network name. It represents a shared directory database, replicated across domain controllers, so authentication and policy decisions remain consistent. When a user signs in, when a computer joins, or when group policy applies, those actions happen within the domain context. This boundary defines where accounts live, which controllers serve them, and how administration is delegated. At the next level, a forest is the top-level security and administrative boundary in Active Directory. Inside a forest, domains share a common schema, configuration, and global catalog relationships, so they are tightly connected. Separate forests, like Contoso and Fabricam, are more independent. A trust creates a controlled authentication path between them. With a one-way trust, access flows only in the trusted direction, so users from one forest may be accepted by the other. With a two-way trust, both forests can authenticate users from the other side. Trusts do not merge administration. They simply allow identity to be recognized across boundaries when permissions allow it. Active Directory becomes real at the domain controller. When a user signs in, the workstation relies on DNS to find an available domain controller. That controller checks the credentials, applies policy, and returns the authentication result. Other domain controllers are not just backups. They replicate directory data, so logons and changes stay consistent across the domain. This is why domain controller health is business critical. If clients cannot locate a healthy controller, authentication slows down or fails. In migration work, always verify DNS, replication, and domain controller readiness before moving users or workloads. Reliability also depends on replication. When a change happens, like a password reset, it is written to one domain controller and then replicated to others. Within a fast headquarters or branch network, that replication can happen quickly. Across slower WAN links, AD uses site links to control when and how data moves, keeping traffic predictable. The goal is simple. Users should authenticate against a nearby domain controller and still receive consistent identity data. Good site design balances freshness, bandwidth, and resilience across the organization. Most Active Directory changes are multi-master, but a few critical operations need a single authority. These are the FSMO roles. 2 operate at the forest level: schema changes and domain naming. 3 operate within each domain: RID allocation, PDC emulator functions, and infrastructure updates. During migrations, these roles matter because they can become hidden dependencies. If the wrong role is offline, tasks like creating security principles, synchronizing time, or changing the forest structure may fail. High availability here is not just adding domain controllers. It means knowing where these roles live, keeping replication and DNS healthy, and having a recovery plan. In everyday administration, 3 object types matter most: users, groups, and computers. A user object represents an identity. Instead of assigning permissions directly to each person, we place identities into groups, then grant the group access to resources. That keeps access easier to audit, change, and remove. Computer objects follow a similar trust model. When a workstation or server joins the domain, AD can recognize it, apply policies, and manage authentication for that device. The key habit is to manage access through structure, not one-off exceptions. Good group design makes security cleaner and migrations much easier. Organizational units are where Active Directory structure becomes operational. You group related users and computers into containers that match how the business works, such as departments, workstations, or servers. Once objects are organized, you can delegate control without handing over full domain admin rights. For example, a help desk team might reset passwords only for one department. Ours also become policy targets, letting group policy apply settings consistently. During migration, this structure deserves careful review, because messy delegation or outdated OUs can carry old operational problems into the new environment. Migration planning is where the AD components start to connect. Domains, sites, domain controllers, devices, groups, and applications all create dependencies. Before changing anything, map what authenticates where, which apps still bind through LDAP, which users sync to cloud services, and which computers must remain domain joined. Also review trusts, group access, and policy paths, because they often explain why something still works. This view helps you avoid treating AD as just a set of servers. It is an identity ecosystem. A good migration plan follows the relationships first, then decides what to move, modernize, retire, or leave in place. You now have the foundation for migration thinking. Active Directory as an interconnected environment, not a single database. Domains, forests, trusts, domain controllers, sites, users, groups, computers, and OUs all shape what must move and what must keep working. Next, we'll go deeper into authentication, authorization, DNS, and group policy, because those services often determine the real migration path.